Assalamualaikum warahmatullahi wabarakatuh. Today, we are from Group 17 or Gryffindor will present about mathematics or finance. Before we continue, my name is Muhammad Haris bin Muhammad Razi and my metric number is 1200879. I will start our presentation today with topic interest. Basically, interest rate can be defined as a surplus amount that a lender charges to his borrower and is a percentage of principal, the amount loaned. There are two types of interest, which is simple interest and compound interest. Simple interest is a quick and easy method of calculating the interest charged on a loan. Simple interest can be calculated by multiplying the daily interest rate by the number of days that elapse between payment. The formula for simple interest is P times I times N, where P is the principal, I is the interest rate, and N is the period. For example, a student took out a simple interest loan of $18,000 to pay his college tuition and was charged an interest rate of 6% for 3 years. By using formula, we can find the simple interest charge by multiplying the $18,000 times 6% times 3 and we get $3,240. The total amount that must be paid by the student within 3 years is $21,240 by adding principal amount with interest charge. Next is compound interest. Compound interest is the interest on a loan or deposit calculated based on both the initial principal and the accumulated interest from previous period. Compound interest will make a sum grow at a faster rate than simple interest. It is because simple interest only calculated the principal amount. The formula for compound interest can be seen as in the slide. Based on this slide, the example for compound interest is we will compute the compound amount when $1,000 was invested for 5 years at the nominal rate 8% that compounded quarterly. In this situation, because the question states that the rate is compounded quarterly, so there is an adjustment need to do before we can calculate the compound amount. As we can see, we must adjust the interest rate by dividing 8% or 0.08 with 4 and the times period adjusted by times 5 years with 4. After that, by using the formula, the answer for the compound amount is $1,485.95. There is one more example for compound interest to make you clear how to calculate the compound interest. That's all, and after this I will pass this presentation to Uwais.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Uwais bin Omar and my matrix number is 1200842. And today I will present about the present value in business mathematics. So yeah. So, what is the meaning by present value? So, present value refers to the amount required now to reach the desired future value. So, the formula is P equivalents to S in the bracket 1 plus I to the power of negative n. So, we can see that how do we get I is from R divided with M, and how we get the n is M times by T. So, yeah. So next we go to the example for present value. So we are going to use the formula. So the example is Jason invested a sum of money 10 years ago in an account that paid interest rate of 8%, compounded monthly. So his investment has grown to $5,682.28. How much was his original investment? So at this question, we need to find the present value for the investment. So given T is 10 because it's 10 years period. So the rate is 0.08 because 8%. So next we're going to the monthly compounded. So in a year, it will compounded in monthly. So we going to have 12 months, and then the S, which is the his future value. So using the formula, we're going to get I. So R divided by M, 0.08 divided by 12, and then M multiplied by T, which is 12 multiplied by 10. So we get 120. So we just put in the formula given. So 500 P equivalent to the 5,682.28 in the bracket 1 plus 0.08 divided by 12 and to the power of negative 120. So we get $2,560 for his present value. Yeah. So next we're going to the single payment trust fund, which is a single payment trust fund. So the example is a trust fund for a child education is being set up by a single payment, so that at the end of 15 years there will be $50,000 if the fund earns interest at rate 7% compounded semi-annually. So it will compound it in 6 months, half of the year. So how much the money should be paid into the fund? So the solution is we're going to as usual, we're going to use the formula given, which is S equivalent to 1 plus I to the power of negative m. So yeah, so we want to present we want to have the present value of the 50,000 due in 50 years. So we get with 50,000 divided by 2, and then is equivalent to 0.035, and then n is 15 times 2, so we get 30. So we have the formula, so we get 70,813.92. So for the single payment, we get the 17,830,000 dollars 0.92 cents should be paid into the fund for the investment for 50,000 in the future value. Alright, thank you. So next we're going to the part of equation of value. So the example is suppose that Mr. Smith owes Mr. Jones two sum of money, which is 100,000 due in 2 years and $600 due in 5 years. If Mr. Smith wishes to pay off the total debt now by a single payment, how much should be the payment be? Assume an interest rate at 5% compounded quarterly. So at this, the single payment act due now must be such as it would grow and eventually pay off the debts when they are due. That is, it must equal the sum of the present values of the future payments, as shown at the figure. We have that x is equivalent to 1,000. For the first payment is 1,000 times with 1.02, which is 1 plus I in that particular payment, to the power of negative 8, plus by 600 multiplies by 1.02 to the power of negative 20. So the equation, so we get that x is equivalent to 1,257.27 for the single payment that Mr. Smith owes with Mr. Jones for the single payment. Alright. So next, the other example for equation of value. So a debt of $3,000 due in 6 years from now is instead to be paid off by 3 payments. So the instruction give that $500 now, 1,500 in 3 years, and the final payments at the end of 5 years. What would this payment be if an interest rate of 6% compounded annually is assumed? So the solution is, let X be the final payment due in 5 years. So for computational convenience, we will set up an equation of value to represent the situation at the end of that time. For in that way, the coefficient of X will be 1, as seen in the figure. Notice that the year 5 we compute the future values of $500 and $1,500 and $1,500, the present value of $3,000. The equation value is 500 to multiplied by 1.06 to the power of 5 to the first payment, but plus with the 3 years, which is 1,500 multiplied over 1.06 to the power of 2, and we plus X, because X represent the final payment for the 5 years for the debt. Yes, so the debt is 3,000, equivalent to 3,000 to the power of 1.06 to the power of 1. So we get we transfer the amount to the right of equation. So we get X is equivalent to 3,000 to the power of 1.06. So we arrange all the number. So we get that X is equivalent to $475.68. Okay. So next we're going to comparing the investment. So suppose that you had the opportunity of $5,000 in a business such that the value of investment after 5 years would be $6,300. On the other hand, you could instead put the $5,000 in a saving account that pays 6% compounded semi-annually. Which investment is better? So now we're going to see how which one ways that will give us more profit. So now let's see how the solution is. So the solution is, let us consider that the value of each investment at the end of 5 years. At that time, the business investment would have a value of $6,300, while the saving account would have a value of 5,000 multiplied by 1.03 to the power of 10, because we follow the present value formula. So we get $6,719.58. Clearly that the better choice is putting the money in the savings account. Because what? Because there is a rate that would give the investment grow up a little bit greater than the saving account. Yeah, that's why. Thank you. Alright, now we're going to the part of net present value. So before we start, I'm going to tell you about the meaning of net present value. So if an initial investment will bring in payments at future times, the payments are called cash flow. So the net present value, denoted as NPV, of the cash flow is defined to be the sum of the present values of the cash flow minus the initial investment. So if NPV is greater than 0, the investment is profitable. Instead, if the NPV is lower than 0, the investment is not profitable. So now we're going to see the example for the net present value. So suppose that you have to invest, suppose that you can invest $2,000 in a business that guarantees you cash flows at the year end of year 2, 3 and 5 as an indicate in the table below. Assume an interest rate of 7% compounded annually and find the net present of the cash flow. So as we can see that the table for the cash flow for year 2 is $10,000, for the year 3 is $8,000, and lastly for year 5 is $6,000. So next we're going to calculate the NPV. So the first thing first, we're going to put the original formula from the present value, which is s to the bracket of 1 plus I to the power of n, negative n. So we get that for the second year, we're going to put $10,000 multiplied by 1.07 to the power of negative 2, plus by third years, which is $8,000 multiplies by 1.07 to the power of negative 3, and then $6,000 multiplies by 1.07 to the power of negative 5, and we must minus with the initial investment, which is $2,000 that we invest. Yeah, so we get that NPV is negative $457.31. Since the NPV is lower than 0, so the business venture is not profitable for us. So if one considers the time value of money, it would be better to invest the 20,000 in a bank paying 7%, since the venture is equivalent investing only $20,000 minus by $457.31 will be equivalent to $90,542.98. Yeah, that's all. So now I will give to Nasir to continue his presentation. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nasir Farid bin Bahaya An-Nasuan. My matrix number is 1200912. Today I want to explain about one subtopic, which is future value. This is simple topic, but firstly we need to understand the two objectives. The first objective that we need to understand and find is what is actually the meaning of the future value, and the second one is what is the concept and item under future value. The concept and item under the future value, which represents the formula for the future value, is S equal to P times 1 plus R to the power of n, and S represent for the accumulated amount after n periods, and P represent the principal, and R represent nominal interest rate per year, and n is time periods. The next one, we need to find and understand the meaning of the future value. What is actually future value? Future value refers to the amount an investment is worth after one or more periods. For the example, we give you the questions. The simplest question. Suppose you invest 100 in your saving account that pays 10% per year. How much will you have in 1 year? From this question, we find that P refers to principal is 100, and R refer to interest rate is 10%, and N refers to the time periods is 1 year. And then you need to put the item into the future value formula. S equal to P that represent 100 in bracket 1 plus R that represent 10% to the power of 1 that which is n, that represent time periods. And if you calculate it, and you will get 110. Before this, we find the investing for one period only. What happen if we invest for more than one period? For example, we give you the questions that is the same question, but what will you have after 2 years? Assuming the interest rate doesn't change, it means that it's same as before, but the time period or n is changed to 2. Before this is for 1 year, and for this questions is 2 year. So we need to put the item into the future value formula, which is 1p equal to 100, and in bracket 1 plus r equal to 1 plus 0.10, that 0.10 is represent for 10% to the power of 2, because it's 2 years, and you will get 121. That is the answer for this question, with the same rate, with the same principle, but it is difference in time period, which is the first one is one for the 1 year, and the second one is for 2 years. Okay, so I will explain about the concept of the general formula for the future value. The future value of $1 invested for n periods at rate of r period is this. Future value equal to $1 times 1 plus r to the power of n, which is n represent time periods and r represent the rate. The expression 1 plus r to the power of n is sometimes called the future value interest factor for $1 invested at r% for n periods. Okay, for example, we just use the same problem, which is going back to our 100 investments. What will you have after 5 years, assuming the interest rate doesn't change? From the same problem, the same principle, the same interest rate, but difference in time periods. So we'll just put the item into the future value formula, which is p is simple, equal to 100, and in bracket 1 plus r represent 10% or 0.10 to the power of 5, because the question asks for 5 years. If the question asks for 3 years, n is 3 years. If the question asks n is 1 year, n is 1 years. But the question for this time asks after 5 years. It means that n is 5 years. Then 100 times with 1 plus r, that is represent 1.10 to the power of 5, you will get 161.05. For the better and deep understandings, I will give you 2 example questions, which is the first one is called, if RM3000 is invested for 4 years at 9% compounded annually, how much is earned after 4 years? First, we need to remember that we need to find item under the future value. It's based on future value formula, which is S equal to P in bracket 1 plus R to the power of N. What is P? The principal. P is equal to 3,000 that we invested in our saving account, and R is equal to 9% that is compounded annually, and N is equal to 4 years, because the question asks for 4 years. So we just put the item into the future value formula, which is P is equal to 3,000 and times in bracket 1 plus R, that represent 9% or 0.09 to the power of 4, and you will get RM4234.74. For the next questions, find the accumulated amount A if 4,000 is invested at 3% for 6 years, compounded monthly. It's a little bit tricky here because before this we just compounded annually. It means year by year. It means one by one. But if the question asks for the compounded monthly, month by month, it means that when you have 12 months, we need to divide it by months. Okay, first we need to find the item under future value and just put it to the future value formula. For the P is, we find that P is 4,000 invested in accounts, and R is 3%, and 3% for 6 years. 6 year is time periods, 6 year, and then compounded monthly. Monthly is 1 year have 12 months, so month is for 12 months. So the interest rate need to divide by months. It means that 3% or 0.03 is divided by 12, and you will get 0.0025. And also the time periods must times with 6 and equal to 72. It's because 6 is years times with 12 months is 72 months. And then you will get the item and just put the item into the future value formula. The future value formula is S equal to P times 1 plus R to the power of N. The P is 4,000 that we invested in the accounts, and 1 plus R, the R is divided by M, that M, and it means that R is 0.0025 to the power of 72. After we times the years, 6 years to 12 months, and we will get 72 for N, and you will get the last answer is RM 4787.79. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amzah Asraf bin Muhammad Sabihi. My matrix number is 1200905. I will explain about effective rate of interest. Effective rate is the interest rate on loan or financial product restated from the nominal interest rate and expressed as the equivalent interest rate if compound interest was payable annual in area. Next, the interest rate that would produce the same accumulated amount in 1 year as the nominal rate compounded m times per year. As you can see below, this is the formula for effective rate of interest. R equals to bracket 1 plus R divided by m the power of m minus 1, which R is nominal interest rate per year and m is number of conversion period of per year. There is an example of effective rate of interest. Find the effective rate that corresponds to a nominal rate of 6% compounded quarterly. The given R is 6% and M is 4. So, we put that figure into a formula, which is 1 plus 0.06 divided by 4 the power of 4 minus 1. So, we get 0.006136. So, the effective rate is about 6.136% per year. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Iman binti Muhammad Nasir and my matric number is 1200864. So today I will present to you about annuity. Annuity is a sequence of payments made at regular time intervals. For example, shop rental, insurance policy premium, and regular deposit to saving accounts. Annuity also can be classified into many classes, such as ordinary simple annuity and simple annuity due. Ordinary simple annuity is a payment made at the end of each payment period, and the payment and compounding frequencies are equal. And next, simple annuity due. Simple annuity due is a payment made at the beginning of each payment period, and the payment and compounding frequencies are also equal. For example, most car loans are ordinary simple annuities where payments are made monthly and interest rates are compounded monthly. As well, car loans do not require the first monthly payment until the end of the first month. And for simple annuity due, for example, most car leases are simple annuity due where payments are made monthly and interest rates are compounded monthly. However, the day you sign the lease is when you must make your first monthly payment. Okay, example to find the future value of ordinary simple annuity. Find the amount of an ordinary annuity. Find the future value of ordinary simple annuity. Find the amount of an ordinary annuity of 36 monthly payments of $250 that earns interest at a rate of 9% per year, compounded monthly. So the solution, given N 36 and R, which is represent present value 250 and the interest rate 0.09, and we need to divide it by 12 because it is compounded monthly, and we can easily get the answer by using the formula of future value of ordinary simple annuity. Okay, next, how to find the present value of ordinary simple annuity. Okay, example. Emma's parents loaned her some money to buy a car. They required that she pay $150 per month for 60 months, with interest charged at 2% per year compounded monthly on the unpaid balance. What was the original amount that Emma borrowed? Okay, so using the formula of present value of ordinary simple annuity, we can easily find the answer. So solution, given R is 150 and the N is 60, which stand for months, 60 months, and the interest rate is 0.02, but we need to divide by 12 because it's compounded monthly. So we can easily get the answer of this question by using the present value of ordinary simple annuity.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Akram Nabil bin Alias. My matrix number is 1200835. So for now, we will proceed with the last topic of our presentation today, which is amortization. Amortization refers to the process of writing down a value of something, usually a loan or intangible asset. For instance, a bank lends a borrower a certain amount of money and charges interest at a fixed rate and to be paid periodically according to the stated agreement. So a loan is amortized when part of each payment is used to pay interest and the remaining part is used to reduce the outstanding principal. Since each payment reduces the outstanding principal, the interest portion of a payment will be decreases as time goes on. This is when amortization will be helpful to provide important information such as the periodic payment, the total interest paid, and the principal contained at a certain period, and many more using the amortization formula. Before we go through the amortization formulas, it is better for us to know what is the alphabet in the formulas representing of. First of all, we have the capital A. Capital A represents the initial amount or the principal amount or the loans amount usually. Next, we have R. R represents the interest rate per period, whether it is monthly, annually, or quarterly. You must adjust it accordingly. Next, we have number of period, which is represented by N. Number of period is how many times do we need to pay the loan. Next, we have R, which is representing periodic payment. Periodic payment is how much do we need to pay per fixed period. Last but not least, we have K, which represents number of terms. Now, let's go through the amortization formulas. There are three formulas that I want to present today, which is the periodic payment, principal outstanding at the beginning of certain period, and the total interest paid formula. First of all, we go through the periodic payment formula. The periodic payment formula is A, which is the initial amount or principal or loans times by interest rate over 1 minus 1 plus R interest rate to the power of negative n is the number of period. If you kick in the number accordingly to the formula, you will get the answer, which is the periodic payment, which is represented by the capital R. Then, in order to calculate the principal outstanding at the beginning of the certain period or case period, you will need the periodic payment, because the formula is the periodic payment or the capital R times 1 minus 1 plus interest rate to the power of negative n, negative number of period, plus k, number of term that you want, minus 1 over the interest rate. Then if you multiply it, then you will get the principal outstanding at the beginning of the certain period or the case period. Lastly, we will talk about the formula of the total interest paid. Total interest paid formula is n times r minus a, which is the number of period you need to pay, times the periodic payment minus the a, which is the initial payment. Then you will get the total interest you will need to pay for the loan or the loan. So now we will proceed with the periodic payment formula. This formula is used to determine the periodic payment needed to be made by the entity to pay back their loan according to the amortization conditions. For instance, a person amortizes a loan of 100,000 ringgit Malaysia for a new car by obtaining a 20-year of mortgage at the annual rate of 7.5% and compounded monthly. So, how much is the monthly payment for the loan that the person made? First of all, we need to identify the important information according to the formula, such as the initial amount, the interest rate, and the number of period. Then only we can determine it and put it in the formula. So we'll get the initial amount of the loan is RM 100,000 ringgit, and the rate is 0.0065% rate per month, because it is given 7.5 rate, but it is for annual. They want the monthly payment, so we need to divide the annual payment by 12, then only we will get the answer. Same goes as the number of period. It is given year, but we need to buy it or we need to pay it monthly. So the number of year needed to be times by 12, because 1 year have 12 months, then we will get the answer. So the answer is given in the slide. Now we'll proceed with the principal outstanding at the beginning of kth period formula. So this formula is used to find the principal remaining of the amortization after certain period. So based on the previous example, how much is the principal remaining after 5 years? According to the formula, the only thing we didn't get yet or we didn't know yet is K. So the K is 61. How do we get that? It is based on the statement of the principal remaining after 5 years. Because the payment is made monthly, we need to times 5 by 12. Then we will get 60. And it is said after 5 years. So the first term after the 5 years is the 61st term. Then we kick in the information accordingly and precisely according to the formula. Then we will get the answer is RM 86,901 ringgit and 75 cents. Last but not least, let's proceed to the total interest paid formula. This formula is used to calculate the total interest paid at a certain period. For instance, according to the previous example, calculate the total interest charges of the amortization. So we need to know the important information for this formula, which is the N, the number of period, and the R, the periodic payment, and the A, the initial amount. In this case, the number of period is 240, the periodic payment is 805 ringgit 59 cents, and the initial amount is RM 100,000 ringgit. And we compute it in the total interest paid formula, which is N times R minus A. We will get the answer is 93,000 RM 93,341 ringgit and 60 cents. So it is the end of our video presentation of Mathematics of Finance chapter, including interest, future value, present value, annuity and amortization, and effective rate. Thank you for your attention and thank you for listening and thank you for your guidance. That's all from us. Assalamualaikum warahmatullahi wabarakatuh.